AI-driven retail and e-commerce. From the plethora of AI use cases in retail and e-commerce, it is clear that AI can help to capture significant gains across this sector's value chain by, for example, delivering a better shopping experience, predicting demand, and automating operations. These smart technology solutions can specifically help to address some of the biggest challenges in retail, such as not having accurate forecasting models to predict trends and levels of demand, poor customer support and services, ineffective targeting, recommendations not being in line with customer preferences and needs, non-optimal store footprints, and having overstock and out-of-stock inventory problems. According to meticulous research, AI's growth in the retail market has been predominantly driven by the increasing adoption of a multi-channel or omni-channel retailing strategy to enhance the personalization, engagement, and end-user customer experience. They projected a compound annual growth rate of 35.9% to reach $15.3 billion by 2025. In order to unlock business value, serve their customers better, and capture these gains, retailers and e-commerce businesses must leverage technology infrastructure and all available data. Although traditional retailers have in general struggled to make the offline to online transition, the growth of advertising technology and e-commerce that generates massive customer data have allowed retailers to optimize their advertising and to target customers in a more effective and efficient fashion. With the wealth of data available in disparate data sets such as loyalty, clickstream, browsing behavior, promotions, in-store, location, customer profiles, customer life stages, channel interaction, pricing, and billing data, a wide range of AI applications are possible that includes demand prediction, offering the right products and services to the right customer at the right time, inventory management, customer management, merchandising and market basket analysis, campaign management and customer loyalty programs, supply chain management, analytics and optimization, event and behavior-based targeting, market and customer segmentations, recommendation engines that help to increase the average order size by recommending complementary products based on predictive analysis for cross-selling, cross-channel analytics, and trend extrapolation. Accenture reports that investment in AI and human-machine collaboration could boost retail store revenues by 38% by 2022. As a result of the growing AI use cases in retail and e-commerce, GSGIR predicted the associated demand and driving labor efficiencies were $54 billion annually, while price optimization and annual sales increase in discretionary categories such as clothing and footwear can amount to $41 billion globally by 2025. A MGI analysis has highlighted some use cases that include optimized pricing, personalized promotions and recommendations, intelligent virtual assistants, automated in-store checkout, completing last-mile delivery by drones, real-time tailoring of website displays, anticipating of demand trends whilst optimizing and automating supplier negotiation and contracting, automating warehouse and store operations, as well as optimizing merchandising, product assortment, and microspace. Some example AI use cases with specific benefits include a 1 to 2% EBIT, earnings before interest and taxes, improvement using machine learning to anticipate fruit and vegetable sales by a European retailer, a 20% stock reduction of a German e-commerce merchant Otto using deep learning on billions of transactional records to predict e-commerce purchases, and 2 million fewer product returns per year. A 30% reduction of stocking time using autonomous vehicles in warehouses of Swiss Log, a 50% improvement of assortment efficiency, 4 to 6% sales increase using geospatial modeling to improve micro-market attractiveness, and 30% online sales increase by using dynamic pricing and personalization. Amazon is a prime example of an extraordinarily successful company in retail and e-commerce that uses AI to develop and maintain their competitive advantage in scalable customer service and experience, as illustrated with their usability, recommendations, and membership benefits. To drive product recommendations, they apply a combination of collaborative filtering and next-in-sequence AI models on their colossal consumer purchases behavior database to make recommendations on the next likely products and/or services that a customer might be interested in purchasing. Amazon also uses state-of-the-art natural language processing to power their digital assistant Alexa, optimizes their logistics with respect to delivery arrival times, accuracy, efficiency, rerouting, and even drone delivery. With smart speaker devices such as Amazon's Echo and Google Home, shoppers can also complete retail orders through express and third-party retailers. Amazon Go, a cashierless grocery store and mobile application that lets shoppers buy items without human interaction, swiping a card or paying cash, is using AI and sensor technology to create a checkout-free shopping experience that automatically detects when products are taken from or returned to the shelves and keep tracks of them in a virtual cart and handles the payment automatically via the mobile application. There are also similar cashier-free convenience stores in Sweden and Finland, as well as in China, where customers can pay via WeChat or other mobile applications. Some examples of where traditional retailers have instrumented their stores with Bluetooth beacons to collect data about customer behaviors and purchasing patterns include Target and Walmart in the US and Carrefour in France, which in turn allows them to apply AI-based models to this data in order to send personalized promotion to their customers whilst they are shopping in store. In the case of Carrefour, the deployment of this smart technology solution in 28 stores has led to a 600% increase in their mobile application users. Another example of improving the shopping experience is IKEA's augmented reality application called Place that allows customers to visualize how IKEA furniture fits into customers' household spaces. Apart from eBay's ShopBot that provides recommendations and advice, they are also experimenting with consumer psychology to better understand consumers using subconscious techniques such as color psychology, persuasive pricing, trust symbols, and marketing triggers for better marketing and helping to optimize conversions. Pinterest introduced a Chrome extension which allows users to search for any product online through an image and allows them to browse similar products by the same retail store. Furniture retailer West Elm scans customers' Pinterest boards to understand their personal style and then generates a matching recommended furniture and home decor item list. Macy's in-store experience has been given a boost with their AI-driven on-call application and chatbot that addresses individual store-related questions about a specific item, directions, or if an item is in stock, but can also pick up if a customer gets frustrated and human intervention is needed. Another in-store example is clothing retailer Uniqlo, who has several stores with U-Mood kiosks that show customers a variety of products and measure their reactions to the style and color via brain signals. AI-driven recommendation engines use state-of-the-art machine learning techniques to predict the likely products that would be of interest to a customer based on a customer's profile, purchase history, and what other customers with a similar profile purchased. It also predicts the likelihood of a purchase, as well as cross-selling and upselling opportunities in next best action applications based on a 360-degree view of customers. These next best actions involve delivering the right offer to the target at the right time and to the right location, offering highly differentiated and tailored products and services, updating customer services representatives with the right profile and preferences, and managing real-time customer interactions through integrated channels and intelligent virtual assistants. An intelligent sales flow assistant can predict the next steps and questions customers may have and feeds them information proactively. This can happen in accordance with customer journey path identification and customers' preferences, which could be via an intelligent virtual assistant, pushed application notifications, a chatbot window that pops up, or a follow-up email. There are many examples of smart agents being used by retailers, which include 1-800-Flowers proposing a selection of floral-related products based on a chat and Stitch Fix that analyzes images that their customers, for example, display on Pinterest to better understand their styles from a clothing perspective. Real-time analytics and insights generation that underpin the development of a holistic and in-depth customer view typically involves contextualized, personalized, and dynamic decision recommendations, fine-grained customer segmentation, geospatial overlay and location-specific recommendations, channel-integrated real-time pricing, identifying communities, leaders and followers, customer stickiness analysis, channel preference and social style-induced segmentations, real-time brand and reputation monitoring and analysis, and store performance analysis. As another AI-driven recommendation example, one of the major retailers in South Africa wanted a smart recommendation and personalization for millions of their loyalty scheme members. To enhance their margins and sales performance, they wanted a deeper understanding of their customers so that they can offer the right products at the right time, thus changing and predicting shopping behavior. Their aim is to meet individual customer needs through relevant personalized communication and offers at scale, which is not possible with traditional methods. By using an AI-driven approach to recommending the right offer at the right time to the right customer will change their shopping behavior. The Cortex solution involved data extracted and modeled for their millions of active customers and their shopping behavior to provide key customer insights. The recommendation engine was trained on historical purchasing data to better segment customers, predict their wants, and offer the products via a defined communication channel. The AI model campaigns are executed through personalized emails, SMSs, and notifications to consenting customers daily to recommend best product offers for each customer and provide the best customer match to product offers that were filtered according to the retailer's specifications. Some of the main barriers for retailers to achieve their supply chain goals are forecasting accuracy and demand variability. To address this, AI-based supply chain optimization in retail can help to reduce write-offs and waste, capital expenditure, and out of stock, enable significant automation, as well as increase freshness, turnover, and efficiency. Such a data-driven solution typically incorporates many influencing factors such as price, individual customer promotions, promotion rules, local competitors, competitor pricing, competitive articles, coupon promotions, media advertisements, print and online promotions, vendor and retailer promotions, seasonality, local holidays, day of the week or month, brand and weather forecast parameters. For replenishment optimization applications, a probabilistic demand forecast machine learning-based model is trained for each product and location over a demand period and also incorporates the replenishment goals and constraints with respect to inventory and deliveries. Automated decisions lead to optimized replenishment orders, which results in significantly reduced waste, out of stock, and manual intervention, and increased availability, but also less items on stock. For spare parts replenishment, a predictive solution can optimize the risk of overcapacity and out-of-stock situations, as the distribution of spare parts from warehouses at different locations are considered with business decisions made on cost versus service level. Warehouses can be optimized and cost of storing, transporting, and unplanned deliveries can be lowered by having a full risk profile on the stock keeping unit level. AI-based price optimization in retail enables increased market share, turnover, raw profit, customers and new customers, significant automation, and a reduction in complaints, returns, and rests at the end of season. Older pricing strategies grapple with how much prices can be increased and by how much, and utilizing economically inconsistent cost-plus pricing strategy that ignores customers, as well as psychological pricing techniques such as 9,99 that does not have statistical evidence of success. Machine learning-based price optimization start with measuring price elasticities by identifying relevant prediction features, calculating relevant price elasticities of demand per store and per product, and learning the continuously changing price-demand relations using relevant data. The price optimization involves the application of strategic price rules, considering location, individual stock levels, storage costs, etc., and applying margin and revenue expectations according to strategic goals. The results are an optimized price per product and shopping or online channel, highest level of automation, and price calculation according to company strategy. The future of AI in the supply chain always starts from customer demand and is completely data-driven and scientific, with demand predictions at the finest grain. It also involves aggregating up the supply chain, breaking down silos and holistic company optimization, exchanging data across supplier-retailer boundaries, planning higher levels, and merging of algorithmic retailing or pricing and the supply chain. Cross-industry partnerships that, for example, include loyalty card providers and banks will also be key to obtaining better customer insights. Over the next few years, we will see retailers starting to know more about what consumers want, and sometimes before they articulate their needs themselves. With advanced applications of AI and smart technology such as natural language processing, facial recognition software, and machine learning, one can expect to see over time intelligent virtual assistants and smart virtual agents that greet consumers in a personalized fashion, anticipate their orders and needs, offer personalized promotions to match their profiles, send offers to their smartphones as they browse through the store, assist with directions, and make recommendations. As mentioned earlier, AI-driven smart technology will more dramatically impact the in-store customer experience with applications such as computer vision that identifies goods bagged by shoppers, smart interactive screens and tabletops that identify articles and recommends complementary and personalized goods and services, non-stop checkout, and automatic payment, as already seen with Amazon Go, and autonomous shopping carts that follow shoppers in the store and find their way to shoppers' vehicles, or autonomous drones for last mile or home delivery. To help maximize revenues, retail stores will also be able to update and optimize prices in real time through the application of AI-driven pricing models that leverage data on customers' profiles, competitors' prices, weather, events, and inventory levels. Inventories can be continuously tracked by AI-enhanced robots that recognize empty shelves and replenish them and help to automate some warehouse activities. With consumers increasingly becoming used to the ease, personalized, and instantaneous nature of online shopping and the increasing use of AI and other smart technology driving revolutionary changes in retail, this might even lead to the possible disintermediation of retailers, especially overbuilt as opposed to asset-light ones, as intelligent systems start to facilitate orders and delivery of goods and services in direct fashion with consumers.